The objective today is to evaluate the criteria needed in setting up a network. So this is very similar to a lesson I've done before called Exploring Network Requirements. But today we're evaluating. So what does the word evaluate mean? It means a principle or standard by which something may be judged or decided. So we're really looking at not just exploring the requirements for a network, but looking at the requirements of a network and then deciding what type of wires or devices to go with. So how do we do that? Well, first I want to challenge you, so let's see if you accept that challenge or not. The second thing we're going to do is look at two types of wired networks. So we're going to really focus on not wireless networks this time, but ones that need some sort of wire. Then we're going to talk about bandwidth rating. That'll be an important criteria when evaluating the types of wires and devices you have in a network. We're going to talk about something called attenuation. Lucky for you, this is the only topic I've really seen the word attenuation used in, so you're not going to get confused with other areas, I suppose. We're going to talk about EFI and RFI. I'll break down those acronyms when I get to it. The sixth thing is the price of fiber optic cabling. So if you haven't seen that lesson already, the fiber optic lesson, go ahead and check that out. The seventh thing we'll talk about is what a main distribution frame is. And that's really, I'm briefly going to talk about that, and I'll just end the lesson after that with one more criteria for you to consider, and then that's it, okay? So here's the challenge for you. Before you learn anything from me, I want you to answer the question, how do you decide how to set up a network? So hopefully you went ahead and wrote down all kinds of ideas you have about things to consider when setting up a network. And then what this means is the rest of the lesson will just be like checks to see if you've checked that item off of your idea list there. It would be nice if we could transport things like they do in Star Trek, just teleport data from one place to the other, but alas, we cannot. Usually networks are more reliable when they're wired networks, so that's the first thing we'll focus on. You have two types of wired networks usually, copper or fiber optics. Now both of these will have a difference in both composition, obviously, speed, and the distance that they can reach. Essentially what we're talking about here is electricity versus light. And then I started thinking to myself, like, what's the difference between these two things? You know, in science class you learn about solids, liquids, and gases. Well, what is light? What is a photon? What is an electron that makes electricity? What's the difference between electricity and electrons? Well, one thing I know is light is fast, like really, really fast. I've memorized that number, 299,100,000 miles per second is the speed of light, or somewhere around that number. That's really fast, right? So what would be the difference in distance that electricity and light can travel? These are more questions for your science teacher in your science class. I'm not going to go into the answers to that, but I do really like these types of questioning strategies. I guess I took you to this site because I just really want you to see this table. Pretty nice table. So the bandwidth difference could be 60 terabits per second and beyond, compared to copper's max would be 10 gigabits per second. Remember, we talk about bits when we're talking about data transfer. We talk about bytes when we're talking about data storage. Now, are these two types of wire future-proof? Well, under fiber optics, it's evolving towards the desktop. So eventually desktops are going to have this. I actually have not seen any in my personal life, but I have seen pictures of desktop computers with these ports in it. And then, of course, for the copper world, Cat6 is the best cable I've ever seen, but there is Cat7 in development apparently. The distance that fiber optics can travel is more than 12 miles at 10,000 megabytes, so that looks like it's what 1,000 megabytes makes 1 gigabyte, so we're talking about 10 gigabytes. Okay, so for over 12 miles, fiber optics can carry the same max that copper has. So that's very impressive compared to this one, which is only at 300 feet. And of course that number is smaller. That's 1,000 megabytes, or just 1 gigabyte. For security, it's nearly impossible to tap, while copper is relatively easy to do so. And if we're talking about the life cycle, this one is going to last a lot longer apparently. And the last thing I should talk about is the amount of energy consumed. Fiber optics is consuming 2 watts per user, so that's a bit lower than 10 watts per user, and of course it varies, so it has less than 10 watts per user. Maybe 10 watts is like the maximum amount that copper cabling would be pulling from a user at one time. So my big takeaway from that article was that fiber optic is more desirable. Later I'll tell you why it's not as common, but for now, according to this website, single mode fiber can reach 40 kilometers, so that's just under 25 miles. On the site I showed you the 12-mile mark. Well, that's just to say at that bit per second rate of 10,000 megabits per second. At the end of the day, we could have a fiber optic cable going 25 miles without a repeater or a hub and still maintain the data that it's sending. So let's talk about a bandwidth rating. This is the number of bits per second that can be sent somewhere. So the way we represent bits on the medium, that is copper or fiber optic, is called the encoding. And you can do speed tests on your computer to see what your bandwidth rating is. And it's always fascinating to me how the download speeds aren't the same as the upload speeds, though we're essentially on the same wire. If we're talking about fiber optics now, we'll have a separate wire sending and a separate wire receiving, but maybe I shouldn't even say the word wire because we're talking about these glass tubes that the photons are bouncing around in. Photons being light. So my question is, why on Ethernet cables, these Cat6 cables, why is the download speed just always so much faster than the upload speed? Isn't the makeup of the wire that's downloading stuff the exact same makeup of the wire that's uploading stuff? But that's just always been something that bothered me and I don't know the answer to. Is it a trick by the ISPs to try to get more money out of us if we are the type of person who's uploading a lot? Maybe you're an aspiring YouTube star and you're just uploading videos often. If I contacted my ISP, can I increase this speed so I can, upload more videos per day maybe? I don't know. Before I move any further, let's talk about this concept of distance. The bits being sent can only travel so far before their signal weakens. So this is called attenuation. This is synonymous with the word loss. So at a certain distance, all these ones and zeros would just become zero because with each step or each foot or maybe each mile, depending on what we're talking about. And another problem that copper cabling has is interference. Not the football kind of interference, but this type of interference is through electromagnetic interference or radio frequency interference. These are both types of interference. And if copper wires are in a bundle, you have this thing called crosstalk that happens because of the interference. This is because the wires are just too close to each other without enough buffer between them, unless you have a foil plastic wrapping over the copper, which is nice and supposed to reduce interference. Crosstalk is definitely not a desirable thing, so this is a bad word. No saying crosstalk in class. Now, because crosstalk can happen, you might not be surprised to learn that this makes eavesdropping possible. A bad guy can definitely tap into your wires and eavesdrop on your data transmission. Now, and if nothing else for me, a very security-minded person, that's why I think fiber optic is amazing, because interference and eavesdropping are just not possible with fiber optics. Though I should never say never because the bad guys always seem to find a way somehow, some way. So far, the criteria we've identified when creating this network of yours in this imaginary place is distance is a criteria to consider, speed, your need for speed, and possible opportunities for both interference and eavesdropping. Now, I'll give you another small one. A big one, but small one, sorry to contradict myself, but the bending radius could be a criteria for you depending on your setup. Bending radius limits the angle at which the cable can be bent. You can see right here, this bend in the wire is so much that this is dark while this is still getting light. Unless the angle of this picture is just off and there is light traveling, but because of the shadows and stuff, I'm not able to see that. The point is, though, that fiber optic cable will have a certain bend radius or a limit that it cannot not bend any more than it already is. And now the last criteria we should talk about is price, of course. So fiber optic cable used to be significantly more expensive than Cat cable. This is a little bit more complex nowadays. In a nutshell, there's just not a big difference in price. I mean, I can't wait till one day we don't have to talk about price anymore. We could just do things that are better for the network, better for people without worrying about it. But for now, I think that is just one of the many factors to consider, which if you're a business person, there are going to be more important things to consider than that small price difference. So I suggest if you are setting up a network, refer to a chart like this. These are basically the things you have to consider. Consider the maximum cable length that your medium of choice can reach. Consider the bandwidth and what your needs are. Consider the bend radius in case you have some tricky corners in the office or something. Consider your ability to install and maintain the wired network. There's cost again. Connector types get crazy, so make sure, this is the most obvious one, make sure your NIC cards are compatible with whatever it is that you're choosing, whether it's Ethernet, Cat cables or fiber optic cables. If security is an issue for you, definitely go with the fiber optics so you have no worries. And maybe you're in a spot where interference is an issue, in which case you gotta go with the fiber optics. If networking becomes a job of yours, you might want to refer to the spaces you build these networks in as either equipment rooms or cabling closets. Typically, we're talking about spaces that may include some or all of these types of devices. You got servers, routers, switches, and other networking equipment. Okay, so now an equipment room that connects all these closets together, these things called IDFs. When you connect many IDFs together, you have a MDF. This is a main distribution frame. Some terminology I think you should know if we're talking about networking. And if the main distribution frame connects many IDFs, I want you to make a guess here. What do you think the IDF acronym stands for? So another term before we wrap up the lesson you should know, because you might hear it, is distribution racks. Now these hold network equipment such as routers, switches, patch panels, and rack-mounted servers. Here's a nice picture for you. These are also called 19-inch racks because the upright rails, these things right here, are 19 inches apart. Well, maybe that's the rail. And so the distance from this to this, where you plug or you can roll this thing into, it's called a 19-inch rack because it's 19 inches apart. The type of equipment they'll be working with, and Home Lab is a great place to go to learn that stuff because you get to learn it through discussion. Apparently, these main distribution frames have backbone cabling, which means these cables are coming in from the floors and roof and walls of a building. And if the distance is over 100 meters, then the backbone cabling is going to be fiber optics, okay? For the reasons we've been discussing so far. Just keep that in mind. Backbone cabling, very often fiber optics. I know I've been promising you the end for a while here, but just a couple more things. The last thing you might want to know is a term called the demarcation point. This is where the LAN ends and the WAN, that is to say the internet, equipment begins. So this will probably be equipment from your ISP. For me, a history guy, think of the historical demarcation lines you learned about in your history class. The Spanish and Portuguese had one. North and South Korea still has one. This is just a point of separation, but in our case, it's for a point of separation for networking equipment. ISP on one side and the client on the other. Now don't forget the simple stuff, like check to make sure the NIC you are connected to has the correct ports to the cable that you have bought for it. Wouldn't that be crazy to buy a bunch of fiber optic cabling because you learned how cool it was in this lesson, then just to find out that your devices don't have fiber optic ports like this. They may only have the Ethernet or Cat 6 cable or Cat 5 cable ports right there. For a DOL, let's imagine you want to set up a network here in our lab. Evaluate what considerations we'll have to make when we choose between cable types right out here in the lab, and also tell me where the MDF or IDF, if we need some, would be. Very creative lesson. If you want to do it on a piece of paper and hand it to me, that'll be fine. Obviously, if you're not in my class, you might want to skip this DOL today, but let me help you get started. So I would start my writing by saying something like, to build a network in our tech lab, I would, and then tell me the first few things you would start to consider to build this wired network. And I realized that word said not, but I meant to say now. Tell me what to use, so what type of cabling you think I should use, and where do you think I should put the things that I'm using.